Madam, K. Sharada, madam. Sharada, madam.
Am I audible, sir?
Yeah, stable, madam. Just I want to check are you present or not. So within 5 minutes we will start, madam.
Okay.
Madam, shall we start, madam? Sharada, madam.
Yes, sir.
Yeah, madam. So if you are permit me, I will introduce your profile to the participants, madam.
Yeah, sir. Please go ahead, sir.
So good afternoon, every participant. Now we are in session 2. So today the session 2 is taken by the K. Sharada, madam. Dr. K. Sharada, working as a associate professor, Department of Information Technology, Geetham, Visakhapatnam. Dr. K. Sharada has 20 years of teaching and research experience. She was awarded a PhD in machine learning approaches for retention, scheduling, and identification of wheel spinning cases in personalized tutoring systems from Andhra University in 2018. She also done consultancy work in document classification, applying deep learning technology in EXA Resorts, Tokyo, Japan. She regularly gives talks in the workshops conducted at Andhra University on data analytics and R programming. When she is not teaching, she likes to take courses on NPTEL and Coursera to keep herself up to date with the latest deployments in data science. It is a great honor to have a such knowledgeable and technically proficient individual as our resource person for this FTP. The session is now yours, madam. Please begin our presentation, madam.
Thank you, sir. Thank you, Prasad, sir.
Please share your screen.
One second, sir.
Okay, madam, no problem. Participants, if you have any questions, last we are giving the chance to you. So first,
Sir, my screen is visible.
Okay,
Sir,
madam.
please respond. Yeah. Okay. So today's
Madam,
topic of the
please
discussion.
run in
Yeah.
slide mode, madam.
Actually, I have opened this in Google Drive.
Okay, madam. Please continue, madam, please.
I think in the Google Drive.
Full screen mode is there somewhere. Full screen mode.
Ma'am, go to view, ma'am.
1 second.
View probably will have the full screen view. Yeah.
Yeah.
Got
Okay,
it.
thank you.
Yeah, it's okay, madam.
Yeah. Okay. Today's topic of discussion is the application of generative AI in marketing analytics. So these are the subtopics of this topic that I would like to discuss: the fundamentals of generative AI and marketing analytics. And we are going to see the implementation of a generative AI model, variational autoencoders, with respect to marketing analytics, followed by application of generative AI in marketing analytics field. The main aim of generative AI is to create new content. The content could be numerical content, or it could be text or image or music or even code. And often the content that is generated from the AI, it is difficult to distinguish from the one which is generated by humans. So the generative AI technology have evolved to an extent that it is hard to differentiate the content that is generated by AI models and the one that is generated by human beings. The four key principles behind the generative AI. The first one is data-driven. The generative AI models are basically data-driven. The models are being trained on massive data sets, and during the training process, they're going to learn the patterns that lie in the data, the structure of the patterns, the relationships among the data and data points in the data. For example, if the data happen to be textual data, it is going to learn the vocabulary of the text, the rules of the vocabulary, that is the syntax, the grammar rules. And so all those the models are going to learn. If the data happens to be image data, then the models are going to learn the different shapes of images, different colors, different texture details of the images, etc. So the basically all the generative AI models are trained on large data sets. And once they are trained, the new content they are going to generate, it is going to resemble the original data. That is the first principle of the generative AI, followed by probabilistic generation. So the data generation that happens with generative AI, it's not a replica of the input data. It is going to it is the content that is generated has statistical fidelity, that is statistical similarities of the original data. It is going to understand the statistical properties of the data on which it has been trained, and it is going to generate the content based on that. So it's the outputs that we get from the generative AI models, basically they do not follow any if-then rules, static if-then rules, but they are basically probabilistic in nature. The output that we get is a combination of the information that it has learned from various features that are present in the data. So that is another principle behind the generative AI. And another aspect of generative AI is continuous learning and refinement. Basically, the generative AI models are not static in nature. They continuously learn as and when new data comes in, and they're going to evolve over a period of time. And coming to the last point, about which many of us, many of the community is being worried with, are they going to replace us? Definitely no. They can help us as a tool in improving the creativity, but they can never replace us. They help us as a tool in improving the performance of the people. So in this, I'm going to talk about the different types of generative models. Uh, Generative adversarial networks, variational autoencoders, autoregressive models, normalizing flow models, and RDMs and transformer-based models. So I'm not going to get in the technical details. I'm just going to give a glance of these different generative models with respect to the different applications for which they were developed. The first one is generative adversarial networks. These are basically neural networks, which and they consist of two neural networks, the generator and the discriminator, and they are trained simultaneously and through a process of computation. The job of the generator is to create the data that resembles the real data that has been trained on, and it slowly adds noise in the data and tries to produce the output uh, that is indistinguishable to the extent possible with a given input. And coming to the discriminator, the task of the discriminator is to distinguish the data that has been created by the generator, whether it is a real data or it is um, a fake data that is generated by the generator. The job of the discriminator is to assess the generator, and it evaluates the authenticity of the inputs and provides feedback. And this competition between the generator and the discriminator continues till both of them improves in their performance. So when we say that they have improved in terms of performance, then the generator is trying to fool the discriminator by improving its output to be as realistic to the original content as possible, while the discriminator gets better and better by identifying the fake data that is generated by the generator. So this is how the GANs work, and basically these are widely used for image generation and video generation and style transfer. The next one is variational autoencoders. The implementation of this we are going to see in today's presentation. Basically, it's a neural network. It has two main components, encoder and decoder. The job of the encoder is to compress the data into the latent space, and in the latent space, the data is represented in terms of probability distribution. The probability distribution of the data, that is the mean and the variation of the data. So the in latent space, the information about the data is represented in terms of interpolations and variations. And in the purpose of the decoder is to reconstruct the data from the latent space into the original data space. And the variational autoencoders, they generate the new data points by sampling the data that is available in the latent space. And they are also very much useful in image generation, where they can create new realistic images. And they're also particularly useful in anomaly detection. They can try to identify the data points which do not fit into the distribution from which they have learned. So, so they're very much useful in anomaly detection. And next is autoregressive models. These are basically statistical models, and their prediction models. They're going to predict the values step by step based on the previous values. They're basically sequential predictors. These models are designed for are developed for handling the language data. So they operate by breaking the process into a step by step, and every time in each step they predict the next value that we see when we are drafting the mails, and when we are typing the text in the Word, we see the this kind of prediction. So behind the Word document, we have these kind of models. During the training, the model tries to learn the conditional dependencies between the patterns, because the dependencies between the earlier words is very much required to predict the next word. Basically, these autoregressive models are meant for handling the language data and for time series forecasting. And next is normalizing flow models. They are generative models. Basically, they take the help of probability distribution such as Gaussian distribution. Basically, during the transformation, during the first phase, what is done is, like, the data is, the transformation happens from in forward and reverse manner. Basically, these are used for estimating the density. Basically, these normalizing flow models, what they do is they collect the samples from simple data distributions, and they try to transform the data from simple data distributions to complex data distributions. So they are basically apt for density estimation in the images, and as well as image generation. So in short, these normalizing flow models, what they do is they collect the samples from the simple distributions, and then they try to transform the data from simple distributions to complex distributions, and then they identify the density distribution of the image. The next one is restricted Boltzmann machines. Basically, the architecture of the restricted Boltzmann machine has two layers, a visible layer and a hidden layer. And in the visible layer, it represents the input data, and hidden layer is basically for capturing the features. And in this particular network, there are no connections within a layer. That is, the connections between the neurons within a layer are restricted. So, and these are trained in a contrast to divergence manner, and the weights are adjusted to minimize the difference between the original data distribution and the reconstructed data distribution while passing through the hidden layers. And basically, the restricted Boltzmann machines are being developed in order to use in recommender systems, where they can help a model to learn the preferences of the user based on the past purchase pattern of the customer. The next one is diffusion models, and basically they work on noise addition and denoising process. Basically, it has two phases. In the first phase, the noise has been added, and on a step-by-step phase, and after that, again in the denoising phase, the noise that has been added by the first phase is gradually being removed, and the original image will be reconstructed. So basically, they are used for image generation, and as well as data denoising the images. That is, the images which has noise can be the noise in the image can be removed, and the high quality images can be generated with the help of this technique. The next generator model is transformer based generator models. Basically, initially they were developed to handle the language data but nowadays they are used for handling the language data as well as image data. And the popular GPT which we see are based on this transformer based models. Basically, they have self-attention mechanism. That is, they try to capture the dependencies that are present in the data. Both the short and long range dependencies are being captured, and the contextual information also being captured while training process. And it has multiple layers, like all the neural networks. It also has multiple layers, and during the self-attention mechanism, during the self-attention phase, the details of the data, that is the dependencies and the contextual information is being learned, and then it has been moved to communicated to feed forward neural networks. Basically, they are used in text generation as well as generating the images based on textual inputs. We can describe an image in terms of text, and then these models can generate the images from the textual descriptions. The next one is energy-based models. Basically, in these models, different energy levels are being assigned to the data points, and the energy function is used for this purpose. And the purpose of this energy function is to assign the lower energy and higher energy to the data points, and the energy is being assigned, like the lower energy is assigned to the points which are observed, and for the unobserved data points, higher energy is being assigned. And during the training process, the model is trained in such a way that the model is trained in a way that the energy is minimized on the observed data and it is maximized on the unobserved data. And basically, these are used for image generation as well as anomaly detection, because the anomaly data points are assigned with higher energy values. So this helps in detecting the anomalies that are present in the images. And next one is conditional generated models. In conditional generated models, apart from generating the output, we can impose conditions. We can impose a set of rules based on which the output will be generated. For example, if we want certain features in the image that is being generated, so we can specify the features that we wish to have in the generated output, and the output is generated by satisfying the requirements that has been imposed. Basically, conditional generated models are used for tasks like image to image translation, where if one image is transferred to another image, that is, we can transfer sketches, hand-drawn sketches, to realistic images, and description of the image in terms of text can be converted into image. So these are some of the applications of conditional generated models. So we can see that the generated models that we have discussed till now, they cater to the different needs. So some are some focus on image generation, some focus on textual data. So depending upon the needs we have, and depending upon the output depending upon the content that we wish to generate, we have different varieties of generated models. So in today's session, we are going to see an implementation of this with respect to the marketing analytics field. And before we move on to that, I would like to give you a brief introduction to the terminology related to marketing analytics, because we being from computer science, this is something new to us. So I would like to briefly tell about the terminology that basic terminology related to marketing analytics. Basically, we have several metrics for measuring the performance of the marketing strategies, and we are going to see those metrics. The first one is awareness metrics. So these awareness metrics try to assess the awareness of the brand among the targeted audience. That is, what is the reach of the brand? That is the number of people who are watching the ad, maybe in the social media uh, or other print media, and how often the discussions happen about the brand in Twitter, on Instagram, etc. So based on these, the awareness metrics will be calculated. And likewise, acquisition metrics. Acquisition metrics, they evaluate the effectiveness of attracting the customers. Uh, how good the advertisement is in attracting the customers. Before we find out that, we should identify like what are the different platforms on which we can run the advertisement. For that, we have to assess, we have to find out the inputs, like how many people normally visit that particular social media platform. For example, if it is website traffic, we try to analyze like how often the people visit that particular website or that particular social media. So, and that also can be assessed through click-through rates and cost per click. They mention like how many people click on the advertisement and how many see it, and the cost that is associated with each click. Next is conversion metrics. They measure the percentage of visitors who take a desired action. The desired action is to purchase the product. So how many people after seeing the advertisement are going to purchase the product? That is measured by means of conversion metrics. So in conversion metrics, the percentage of visitors who make a purchase through e-commerce website, and the number of people who would like to avail a service, and then they have filled in the form from a particular website, and the number of users who have put the items in the cart and they have abandoned the cart. They have not they did not go to purchase of the particular items. Next one is retention metrics. So in retention metrics, they assess the in retention metrics tries to assess the so they try to assess the ability of the business to retain the customers over a period of time. That is the retention of the customers. This is measured by means of customer lifetime value. Calculating the total revenue of the customer is expected to generate over the lifetime of the customer. Churn rate, that is the customers who have moved away from the that particular brand and who stopped using the services of that particular brand. And next is the repeat purchase rate. That is how often the customers are repeatedly making the purchase. And those aspects are considered in measuring the retention metrics. And overall business impact, that is overall what is the business impact of the particular marketing strategy, that is what is the return on investment. So measuring the profit that is generated from the marketing activities compared to their cost, and what is the share of the market, that is the total sales that particular company is making in the industry. And customer satisfaction, this can be calculated. This can be found by means of feedbacks and surveys, etc. And these metrics that we have discussed provide various insights into the different aspects of the marketing strategy. They help in understanding the business and improving the and they try to attract and convert, retain, and satisfy the customers. These are some of the metrics with which we can gauge the performance of the marketing. Some of the traditional marketing approaches are by means of radio and TV advertisements, which we are familiar with. These are the popular advertisement approaches that we often come across. TV can cater to the broader audience, and radio can be with the help of radio advertisements, we can target to a local audience. And billboards are another popular advertisements. We often find them on highways, high traffic areas, and busy streets. And with the help of billboards, we can promote the brand. We can create more brand awareness. And next one is direct mail. That is communicating the postcards, flyers, and catalogs to the customers' mailboxes. This is more personal. This is more personalized to a particular segment of the customers. And next is print advertisements, which we often find in newspapers and magazines. And they come in different formats, like classified ads, display ads, etc. And through these, the marketing is done to a target audience. Next is event marketing. In event marketing, normally the companies sponsor the events such as trade shows, conferences, and community gatherings. And through the event marketing, the the business can be taken to the next level. The marketing can be done to the next level, and the target audience can be reached in person. It helps in building the relationships, customer relationships. And the last one, which we often come across, cold calling. This involves calling the customers by phone, by introducing the new products or services. And this cold calling, it requires a skilled sales team, and it is time consuming, and it's a time consuming way of advertisement. Limitations of traditional marketing strategies. Since the data that is generated from these traditional marketing strategies, they come from different sources, and it is hard to analyze the data. And taking this swift decisions is very difficult because of the not availability of the data, and we cannot perform any, we cannot find any patterns because of the not availability of the data. So these are some of the drawbacks of the traditional marketing strategies. Data collection and pre-processing. So data is very, very important in AI models. In building AI models, the quality of the data is influenced by the quality of the output that we get is influenced by the quality of the input data. High quality data obviously yields high quality outputs, while poor quality data can lead to misleading results. So, and the decisions that we make based on the output that we get after the analysis is going to make a lot of difference to the business, because we make informed decision making, and if that is made on poor quality data, then the decisions that are made after the analysis may not bring fruitful results. So the seeing that the data that is given to the AI models is of good quality. So for that, we have to make sure that we pre-process the data and make the data ready before we give the data to the generator models. Here I'm trying to show you a faker package, with the help of which we can generate a sample data and then try to pre-process the sample data. I'm trying to install this. I'm trying to pre-process the data using this Google Colab. So Faker is a package which comes with several methods, with the help of which we can generate sample data. So I have installed the Faker package, and then moving on, I have imported pandas and then Faker, and then you can see here I have written a function to generate the product to generate 100 rows of data with the 3 columns: the product name, the product price, and product description.
Excuse me, madam. Screen is not visible. The code is not visible on the screen.
1 second, sir. Yeah, I hope it is visible now.
Yes, madam. Yes, it's visible.
Yeah.
Yes,
So
ma'am.
initially I have installed the Faker package, and then moving on, I have written a function which is going to generate the product data. So for that, I have imported pandas and Faker, and you can see here a function has been written, and so it has. So I initially have written a function which is going to create 100 products, that is 100 rows of data with 3 columns. And you can see here there are several methods available here. Yeah, see, for product name, what I have done is I've taken the help of the methods that are available in this Faker package. So there is a method called word, and what I have done is I have tried to randomly get 2 words. The first letter of the word is capital letter, and I try to join them. So randomly it is going to pick some word, and then it is going to join those 2 words, and that will be considered as the product name. Likewise, product price and product description I have created. So for description, since I require sentences, I have taken the help of the text method, and I have mentioned the number of characteristics within each description as 200. So I have added these 3, and then you can see I'll execute this. So then I'm calling this, I'm calling the name of this function is generate underscore product underscore data. I'm calling this function. So you can see here, we have generated data with the 3 columns, the name of the product. You can see here the name. It has just randomly picked some 2 words and then try to join them into one, and we call it as product name. And the price, I think the price I have mentioned. Yeah, I have given the details, like it should have 2 digit. The price of the product should be in 2 digit in nature. So that is why you can see the price in 2 digits and the description of the product. And we try to do the data pre-processing. So for that, we take the help of min-max scaler, which is going to transform the data. Here we have, in this data, we have only one numeric data, that is price, and the price, it is 2 digits, so it ranges from 00 to 99. And if we wish to normalize the price to a scale of 0 to 1, we can do so with the help of a function called min-max scaler function. So I have just taken the help of this and tried to transform the price. And once the, yeah, now the price of the product is lying between 0 to 1. So in this way, we can transform the data, numerical data. And if I wish to remove any special characters that are present in the description of the in the description column, so then I can I have done so with the help of a function called clean underscore text. I have written a function for this, And I have taken the help of a method called RE, which is going to replace. And so if it come across anything than this, it is going to replace that with a just with a blank. You can see here, this is the blank. So it is going to replace, apart from capital letters A to Z and small letters A to Z, anything else it comes across, it is going to replace that with a blank. And the text thus obtained is converted into lowercase. So we'll run it and see. We try to apply it on the data description. So you can see here. So because in the description we have not come across many special characters in this we are not able to see. Otherwise, we can see the special characters are being removed. I think the dot has been removed. And earlier, yeah, there is a dot, and the dot has been removed. Dot is also a special character. You can see the converted text from some of the first starting sentence starting word is in capital letter, that has been removed here. So likewise, say for the small data that I have created here randomly, I have done some of the data pre-processing, which I feel is relevant for the task that I wish to perform on this data. So depending upon the task we wish to perform, we have to apply the appropriate data pre-processing techniques, and we have to make sure that before we apply the algorithm onto the data, we have to make sure that the data is clean. So next one is generative adversarial networks. We have already seen this. I'm not going to go into the details, just a brief overview. It has been developed in 2014, and it basically comprises of two components, generator and discriminator. And the goals of these two are different. The goal of the discriminator is to break the generator, and the goal of the generator is to break the discriminator. Both of them are trained simultaneously with the data, and in the process they will improve themselves, the generator and the discriminator. And we try to evaluate the performance of the generator either manually by checking the output or by using evaluation metrics. If we feel that the output that is generated from the generator model is not sufficient, then we can try to adjust the architecture and adjust the hyperparameters and continue the learning process till the desired output is obtained. So basically, this uses double feedback loop because the generator aims to produce the data that fools the discriminator, and the discriminator aims to better distinguish the real from the fake data. So the competition between this generator and the discriminator, it tries to improve both the neural networks, and thus resulting in high quality synthetic images that we get from them. Next one is variational autoencoders. And in variational autoencoders, basically they combine the neural networks with it's a combination of neural network concept with probabilistic approach. That is, we follow the data distribution of the input images in order to generate the output images. And basically, the variational autoencoders has two modules: encoder module and decoder module. In the encoder, what it does is it is going to transform the input images into a latent space, and in the latent space, it will not represent the data point as it is, but the data is represented by means of a mean and data standard deviation. And the data representation in the latent space is basically of lower dimensional in nature. And the decoder job is to reconstruct the image from the latent space. From the data distribution, it should reconstruct the output image. Basically, it uses a small trick. What it does is to learn the gradients. Initially, it is going to take the samples from the Gaussian distribution. Instead of taking the mean and variance from the Gaussian distribution, it is going to start with standard normal distribution. That is, in standard normal distribution, the mean is 0 and the standard deviation is 1. So it is going to start with the standard normal distribution, and gradually it's going to move towards the given mean and the given standard deviation. So, and this trick allows the gradients to flow through the sampling during the training process. So the data decoding, it is going to reconstruct the input data from the samples taken from the latent space distribution. So basically, this VAs, they make use of two loss components, that is mean squared error. So in this, it is going to check the decoded data with the original data, and the difference between these will be considered as mean squared error. And that is one aspect, and another is like it is going to make use of KL divergence. That is, it is going to measure the difference between the encoded distribution and the prior distribution. So these are the two aspects that will be considered during the training process. Okay, now I'm going to show you a working model of variational autoencoders with respect to marketing analytics. Am I running late?
Yes, ma'am. Yeah, we can see.
So with this, I will conclude. You can see here, I have imported the pandas and numpy, and what I have done is, instead of taking the data, I have just randomly created the data. You can see here. So the data has basically customer ID, age, annual income, spending score. Spending score, it represents how often the customer visits the store and make purchases, and website visits, social media activity. So these are some of the parameters that are being considered here. And so with this, I have created the data. You can see here, I think around 100 samples are being created, 100 rows are being created. And these are the columns. And followed by, so and any pre-processing is required here. I think customer ID, it is unique to every row, so we should drop it. And you can see the numbers in different columns are ranging, have different ranges. So we can normalize the data so that the larger numbers do not dominate the smaller numbers. So for that, we have to pre-process the data, and you can see here during the pre-processing. So for the pre-processing, I have taken the help of standard scalar method, which is available in sklearn. You can see here I have dropped the customer ID. So the data is in DF data frame. So the data is in DF, and I have dropped the column customer ID. And I assume that the spending score is the target variable, that is the variable to be predicted. And we have divided the data into train and test data. Since we have 100 samples, I have taken the test size as 2, that is 20% of the data as test data. And then I have applied the, and onto that I have applied the transform function so that all the columns ranges will fall in one range, that is from 0 to 1. And then, so with this, we are done with the step 1 is to create the data. Step 2 is to pre-process the data. And then we are ready to apply the model. And this VAE, it has 2 components, encoder component and a decoder component. You can see here I have created a function with these 2 components, encoder and decoder. And in the encoder, it has the input layer. The input layer equal to the shape. Shape is equal to input shape. Input shape here is equal to the shape of the training data set. That is the number of features that are present in the training data set. After removing the customer ID, we are left with how many features? 1, 2, 3, 4, 5. So that becomes the shape of the input layer, and then followed by a feed-forward dense layer with 64 neurons. The output from the input layer is given here, and followed by a neural network, dense neural network with 2 neurons, and they capture the mean information of the input data. And the output of this is given to the next layer with 2 neurons. And in this layer, we capture the variance, log variance information of the input data. And here you can see the model has been built. The model has been built with 3 layers, followed by a decoder component. In the decoder component, the first layer is a layer with 2 neurons, followed by a dense layer with 64 neurons, and then followed by another dense layer, which is equal to the input shape, is the input number of attributes in the given data set. So then we have combined all these 3 layers into decoder module, and we are with this. We have done with the encoder and decoder. We have defined the encoder and decoder, the number of layers that are required. See this, I have done keeping in view of the requirements of the data that I have. So depending upon the data that we have, we can increase the number of layers, increase the number of neurons in each layer. So once that is done, the function has been defined. Now, what we try to do is we try to generate new profiles. See, we initially have certain profiles with us. Customer for each, we have different group of profiles. Initially, we have trained the model with 100 profiles, and after the training, it is in a position to generate new profiles. and I'm trying to print the new profiles using this function, print profiles. And the print profiles is going to call this function called generate new profiles. In the generate new profiles, I'm going to call the decoder method. I'm going to pass the sample that I would like to predict. Let me execute this. So since I have given a format used by the help of the print statement, so I got the profile information like this. So these are generated by the generator model. You can see an age, annual income, spending score, website visits, and social media activity. You can see that these are not there in the data that we have initially created. So these are something new which are generated by the generator model. Actually, this 49.92 years will not make any sense. We have to round this number. Likewise, spending score, because it is going to range on a scale of 1 to 100, it should be integers, but it has given it in terms of real numbers. Actually, we have to round up these numbers. So this is how. So I have used this in order to generate new profiles based on the existing customer profiles. I have generated a new customer profiles with the help of VAA. So in this way, we can apply the generative AI in marketing analytics, and these are some of the fields wherein we can try out applying the generative AI. Personalized marketing strategies, personalized ads based on the interests of the customer. Preparing the personalized ads is one area, and grouping the customers based on their common interests, and then running the advertisements for the group of customers is another area. Content generation, we can take the help of generative AI models in content generation of the ads, both the textual content, image content, audio, any content that is required for creating the ads. We can take the help of generative AI models. And predictive modeling, that is whether the customers can be retained for their lifetime, can also be checked with the help of generative AI. These are some of the areas you can try on applying generative AI. Actually, I thought of giving in detail information about each of these, but keeping in view of the time constraint, I'm not going into those details. That's it for today's session. Any queries?
Participants' questions. Participants, any questions, any queries?
No, sir.
Thank you, madam. Thank you, madam. Thank you on behalf of Shri Vishnu Engineering College for Women and Department of Computer Science and Engineering. We extend our heartfelt gratitude for accepting our invitation and delivering an excellent and informative session on market analytics research domain, which gives insights and provide our research with valuable ideas and grateful benefiting their work using various tools. Thank you for your valuable speech once again, madam. Thank you, madam.
Thank you, sir, for giving me the opportunity. Thank you all. All the best.
Madam,
Yes, sir.
the case study what you have shown is related to the content generation, or what category it belongs to?
The one I have shown It's not content generation, it is data generation. In the data that I have has only 100 rows. So from the information, I have generated more rows.
Okay, ma'am. Thank you.
Thank you, madam.
Okay, sir. I'm leaving, sir.
Okay, thank you.
No, ma'am.